Chapter 10, Section 4 in the 7th grade note-taking guide is entitled Surface Area of Prisms and Cylinders. So we're switching from volume to surface area. As you know, volume is how much space something can hold or how much space it takes up on Earth, depending on what we're looking at here. If we were talking about a box that I was going to mail, how much could that box hold would be the box's volume. Or if I was talking about the whole box, I could say how much volume or how much space does this box take up on the truck. That's its volume. All right, we're not talking about the volume anymore. We've been talking about volume for the last several days. Now we're going to switch to surface area. So if I go back to that example of a box I'm mailing, the surface area would be the area of all the pieces I can lay my hands on. All the rectangles that make up the sides of the box, if I could find the area of each of those and put them together, that would be the surface area. Now the big problem with finding the surface area is just that. It's all these different pieces that I have to find the area of. I don't want to do that because that's going to end up being probably 6 different calculations at least just for a simple shape before I can go about finding the surface area. So they go ahead and start teaching us formulas here to find the surface area, and that's what they're about to show us. So a net, which is one of the ideas here, is a pattern of a 2-dimensional figure that can be folded to form a 3D figure. So if I were to take that box that I was mailing and cut up that box along all the edges, so I had all the 6 different rectangles that made up the box there just laid out flat, that would basically be the net. And again, I could find this area of each one of those pieces, each one of those rectangles, and add them together, and that would give me the surface area. Okay, and as you can see, that's great because that's the next definition. The surface area is the sum of the areas of the faces or surfaces of the 3-dimensional figure. That's exactly what it would be. But we have some more specific terms related to that. We have the idea of a lateral face. That's one of the parallelogram faces that connect the bases in a prism. So once I identify the bases in the prism, remember the bases are the things there's going to be 2 of. So if we're talking about a triangular prism, the 2 triangles are my bases. And then you've got all these rectangles that are probably going to go around to connect those triangles. Those rectangles are the lateral faces. If you want, I can draw it quick here so you can see what I'm talking about. Here's my triangular prism. All right, the thing there's 2 of are the triangles. So those here are the bases. Then you've got these rectangles that go around this way. All right, those are going to be what they call the lateral faces by definition, because those are the rectangles that get me from base to base. All right, and then we've got the lateral area, which is going to be what I have when I put the areas of those 3 rectangles together here. All right, so let's put all that together here and start solving. Now, as you can see, we're finding the surface area of a prism here, but what's nice is the first thing they give us here is the formula, 2b plus ph. Some explanation would be in order. B is the area of the base. That's not the first time you've seen the area of the base because we've done that with volume. So whenever you are asked to find B, you're computing the area of the base. P, that's a new one. We haven't seen P yet. P is related to the base though as well. It's the perimeter of the base. What you get when you add up the sides going around whatever the base were to happen to be, which we know how to find perimeter because we have done perimeter. We just haven't done it in terms of these 3D shapes yet. And then H, that's an old friend as well from the 3D shapes when we were doing volume. H is the height, how tall the whole prism is. All right, so start off here, we're going to find the 2B part. Right, so B again is the area of base. Well, if I look at this, it's sitting on this base, this 15 by 7 rectangle down here at the bottom. So to find B, I'm going to multiply together 15 and 7. And if you're wondering where the 2 came from in front, it's real simple. There's 2 bases. All right, you've got the one that's on the bottom that we would commonly view as the base. And remember, in a prism, there's 2. There's this one up top as well. So that's why it's 2 bases, because they're finding the area of both of these guys put together in that first part. So I've got 2 times 15 times 7. 2 times 15 is 30. 30 times 7 is 210. All right, then I've got the P times H part. Now the P times H part is me finding the lateral area, the area of these rectangles that go around the shape that aren't the top and the bottom, the bases. All right, to find that, it says P times H. So I got to find the perimeter of the base and then multiply that by the height. So if I find the perimeter of the base, that's 15 and 7, and then another 15 and 7 over here. So I've got two 15s and two 7s, in other words known as 14 and 30, which go together to make 44. And I'm going to multiply that by the height, how tall this whole guy is, and that's going to give me 9. Realize what they've really just done is, if we were talking about the net, a flat representation of this, if I just laid those 4 pieces out flat, all right, found the distance across the bottom, all right, that would be my 44, and then my height would be how tall it is. So it's really just me finding the area of a giant rectangle as I lay it out flat, 44 times 9. 44 times 9 is going to change into 396. So to find the surface area here, I'm doing 210 plus 396. 210 plus 396 is going to change into 606. So the surface area of the prism is about 606 square inches. All right, now here's a cylinder. These are the same section because just like with volume, they share the same formula. The only thing is, as again with volume, we can make the formula now circle specific because the base here is guaranteed to be a circle if we're talking about a cylinder. Not so in a prism. In a prism, base can be pretty much any sided figure, anything but a circle really. But here, since we're guaranteed to have a circle, they're going to change the stuff that talks about the base into the formula for the base. If you remember, the first part of the formula there said 2 times the area of the base. Well, here it says 2 pi r squared. Well, pi r squared is how we find the area of a circle, so that's the same. And then as we look at the right part there, if we remember back to what we just did, it was the perimeter of the base times the height. Well, the height, as you can see, is there. Where it said perimeter, now it says 2 pi r. Well, if you remember, 2 pi r is how we find the circumference of a circle, the distance around the shape. Remember, we don't call it perimeter because we can't measure it, but it's the same idea. It's the distance around the shape. So indeed, these are the same formulas. They're just expressed in different ways based on what we do know or don't know about the shape. So we've got a cylinder here, and as you can see, it's kind of laying down. We can picture it standing up in our head if we need to, but clearly the radius is marked at 6. And that means, of course, the height is 8.3. So the formula says I'm going to take 2, multiply that by 3.14, and then multiply that by the radius squared, 6 squared. I'm going to add to that the product of 2 and pi, which is 3.14, and the radius, which is 6, and the height, which is 8.3. All right, so on the first part there, I've got 2 times 3.14 times 6 squared. 2 times 3.14 times 36 is going to change into 226.08. Right side, I've got 2 times 3.14 times 6 times 8.3. When I do that, I get 312.744. Adding these two guys together, so that's what the formula says to do. That's 538.824. And then the directions say round to the nearest tenth, so we're going to say 538.8. So the surface area of that cylinder is about 538.8 square feet. Realize what the formula has done here. I think it's easy to see, especially when we put it in terms of what we did in the last question. The first part there is 2 times the area of a circle. Well, obviously we have 2 circles here, so part of finding the surface area would be 2 circles. When we talk about 2 pi r h, that's this curved piece that goes around the shape here. Well, if I unfolded that, that would be a rectangle. So rectangle would be length times the width. Well, if I do 2 pi r, that's the distance around that rectangular piece. That would be this guy. And then the height would be this guy, which would be the same as the width. So 2 pi r h is a clever way, really, of me finding the area of that rectangular piece that is bent to make that curved piece that goes around and connects the 2 bases there. So as you can see, finding the surface area here by formula really just kind of makes logical sense, just dissecting the formula a little bit here. All right, let's go on to the next one. The next one is a composite figure here. It's a playhouse, and we're supposed to find the area of the composite figure. Remember, a composite figure is just two shapes or more shapes put together here. We've really spent a lot of time on two-dimensional composite shapes, maybe not as much here on three-dimensional, but here we go. All right, so they want us to find the surface area of this playhouse. As you can see, the bottom is a rectangular prism. Let's go ahead and start off with that because that's the first thing they're asking us for. And the top piece is a triangular prism. The base here has the rectangular prism has a base that measures 3 by 4, and that whole prism is 2 feet tall. When we talk about the triangular prism, remember the base of a prism is the thing there's two of. Well, there's 3 rectangles going around here, so it can't be those. So the base is actually the triangle here. Well, the triangle here is too tall, and this would be how far it is across. And as we can see down looking to the bottom of the rectangle, we see that that's 3. So the base of the roof is 2 by 3. And how tall it is, well, again, it's laying down if this is my base. So this is my height here, which is marked at 4. And now I have all the figures I need to find the surface area of the composite figure. Now, what I don't want you to do is make a real easy mistake to make here. Say, oh, I'm going to find the surface area of this and find the surface area of this and put them together. Not exactly. If we're talking about this rectangular prism, the top of the box here, the top of the prism, is inside the house. It's no longer part of the surface, part of the outside pieces that I can touch. So I can go ahead and find the surface area of this bottom piece, but I want to subtract off the lid here, the top that's really in the roof, because it's not on the surface anymore. It's inside the house. It won't be there. There's not going to be anything there because it's going up into this roof. Same thing for this triangular prism. This bottom piece of the triangular prism, and I guess I should be careful when I say bottom piece because this is the base, but I'm talking about this bottom rectangle here. That would be right there. Also happens to be exactly the same as the lid of the rectangular prism at bottom. Isn't going to be there either. So I want to make sure when I find the surface area of the triangular prism, I subtract that guy off as well. So I can find the surface area of both of these and add them together, but I'm going to have to subtract this rectangular piece off twice because it's not in either shape. And that's a mistake that's really easy to make, but as you'll see, they're going to account for that in the formulas here. All right, now what they did here is they drew the nets of the shape. The nets are the 2D representations of the 3D shapes. Again, if I took scissors and cut along the edges, what shapes would I have? Now the reason those two pieces are white there and the others are shaded, these are those two pieces that I said were the top of the rectangular prism, the top of the box, the lid there, and this is the bottom of the roof piece, which aren't there because they're inside. They're not on the surface. So again, those are the pieces we're subtracting off there. That's why they're there shaded in white, because we're going to have to remember to take those off. So let's start with the rectangular prism. Now as you can see, the formula is different here because we've only got that one base. We're subtracting off this other one. So instead of 2b plus ph, they wrote b plus ph instead. Again, we don't need that other base. It's not there. So the formula says find the area of the base, this 4 by 3 piece, which is of course 12. And I'm going to add to that the perimeter of that same piece. So that's 4 and 3 and 4 and 3, which is of course 14. Oh, I'm sorry here. This should not say 12. This should say 4 times 3. The next one down should say 12. Not a big deal. And then multiplying this over here, the p that I just found, 14, 4 and 4, 3 and 3, adds together to make 14, times the height, how tall that whole guy is, which is 2. 14 times 2 is 28, so we've got 12 plus 28 there, which is going to change into 40. So the surface area of the box at the bottom, minus the lid, because the roof there is not going to exist because it goes up, all right, is 40. All right, now I'm going to find the surface area of the triangular prism piece, the surface area of the roof. Okay. Now, as you can see, it's a little bit different again because they're subtracting off that extra piece that we don't need. they're subtracting off this rectangle here. That would be the bottom rectangle in the triangular prism. So that's why this minus LW has already appeared here, because they're going to subtract the area of the bottom of the prism since it isn't there. All right, so to find the surface area of the triangular prism, I'm multiplying together a half, its base, and its height. Remember, that's the formula for area of a triangle, so it's not something new here. It just happens that the base here is a triangle, so they're using the triangle formula. Makes sense. So half times how long is its base, that's this here 3, times the height, how tall it is 2. Remember, the base and the height of a triangle have to meet at a right angle. All right, now I'm going to add to that the perimeter of the same base times the height. Now that's where I need these 2.5s. Then you've been wondering, why are those 2.5s there? Because I have to find the perimeter going around here. So they're showing us that the left and the right side of the triangle are 2.5 each. 2.5 and 2.5 is 5. And we already said the base piece here is 3 by looking to the bottom of the rectangle. So the perimeter of the base is 8 times how tall that whole guy is. Well, remember, it's laying down because we're staring at the base here of the triangle. So how tall this guy is, if I stood it up, we can see from this side of the rectangle that's 4. And I'm going to subtract from that length times width. That bottom rectangle has to come off here. So we're taking off this 3 by 4 rectangle here that I shaded in red. And we just simply read down to the bottom because it's the same rectangle. All right, well, let's simplify. 2 times a half is 1, and 3 times 2 is 6. 1 times 6 is 6. 8 times 4 in the middle there is 32, and 3 times 4 at the end there changes into 12. So this is 6 plus 32 minus 12. 32 minus 12 is 20, plus 6 is 26. So the top piece is 26, and as we saw from the slide a minute ago, the bottom piece is 40. So I've got 40 and 26. So for me to find the total surface area here, I just have to add 40 and 26. When I add those guys together, 40 and 26 go together to make 66. So the surface area of the playhouse is 66 square feet. Now what they're doing here in the estimation step in step 4 is they're saying, okay, I've got this dollhouse now. Let's pretend I was just sticking it in the box I was going to ship it in, basically. So I was going to ship it in a box that's a nice, clean, rectangular prism here. So if it fits inside that, it's got to have a surface area that's less than the surface area of just that box, because obviously it's not taking up like these places here. So let's find the surface area of the box it would ship in and make sure that it's less, or make sure that the surface area of the playhouse is less than that. All right? So what they're saying here is the base would be the same, the bottom piece, the rectangle that it's going to fit in, all right, because the box here is going to fit in nice and snug. Base is the same rectangle. Same for the perimeter of the base. Same rectangle there. So here, as we go back, we already figured out back here that the base here, bottom piece here, was 12, and we figured out that the perimeter of the base was 14. Those aren't going to change. What is going to change here is the height, not so much in that the height of the whole thing isn't changing, but the height of, we're not looking at one piece, we're just saying, okay, if this is this tall and this is this tall, we just have one height now all of a sudden. So the height that they've suggested here is 4 feet. Well, when I do 2 times 4 times 3 plus 14 times 4, that's going to change into equaling here what is, should be 70 if I'm not mistaken. I'm sorry, 80. When I add those up, that's 80, as in 80 square feet. Well, we said the surface area was 66. Well, that makes sense because it would have less surface area, as we can see, because, for instance, in the box, this space is not being covered, this space is not being covered. So yes, there is less surface area inside than outside of the box. So since the 66 number is less than 80, and clearly it's going to fit in the box, because that would be the whole point of having a box here, our answer is thus reasonable. All right, so let's find the surface area of the prism here. Again, the formula here for finding the surface area of the prism is 2b plus ph. B is the area of the base. Well, that's this rectangular piece down here, which is 6 by 3 or 18. P is the perimeter of the base. What I get when I add up the four sides going around the bottom there, 6 and 3 and 6 and 3. Well, that's the same as 9 and 9 or 18. Times the height, how tall the whole prism is. Well, that's clearly marked here at 4. So I'm going to simplify that down a little bit. 2 times 18 is 36. And 4 18s makes 72. When I add up 36 and 72, the result here, 36 and 72, yields a result of 108 square inches. As we look at the cylinder here in this question, same formula, but again, they've made that formula circle specific. So we're going to say 2 pi r squared plus 2 pi rh. So 2 times pi, which is 3.14, times the radius squared. Well, the radius here is marked at 9, so that's going to be 9 squared, plus 2 times 3.14, times the radius, which is again marked at 9, times the height, which is marked at 20. All right, so some order of operations here. I got to do this whole chunk first, but only after I've done the exponent. Then I got to come over here and do this chunk. So I got 2 times 3.14 times 9 squared. 2 times 3.14 times 81 is 508.68. Over here, I've got 2 times 3.14 times 9 times 20, which is going to be 1130.4. I'm going to add those guys together. 1130.4 plus 508.68 is going to change into 1639.08, which is great because that's my surface area, and that's going to be in feet squared.